Hi everyone, welcome back to my channel. In this lesson, you will learn to describe and illustrate the rectangular coordinate system and its uses. You will also learn to describe and plot positions on the coordinate plane using the coordinate axis. To fully understand the mathematical characteristics of lines and curves represented by their equations, it is important to picture them in a plane. But before we discuss rectangular system, first, let's give emphasis who bridged the gap between algebra and geometry. I want you to meet the father of modern mathematics. René Descartes has been dubbed the father of modern philosophy, but he was also one of the key figures in the scientific revolution of the 17th century and is sometimes considered the first of the modern school of mathematics. It was in La Géométrie that Descartes first proposed that each point in two dimensions can be described by two numbers on a plane, one giving the point's horizontal location and the other the vertical location, which have come to be known as Cartesian coordinates. He used perpendicular lines or axes crossing at a point called the origin to measure the horizontal or the x and the vertical y locations, both positive and negative, thus effectively dividing the plane up into 4 quadrants. Before I illustrate the rectangular coordinate system, let us try to recall some of the topic that is related in this lesson. Do you remember the parts of a number line? A number line is a picture representation of real numbers evenly laid out on a straight line, wherein 0 is the origin located in the middle part of the number line. Can you tell me the integers that can be seen on the left side of 0? The integers on the left side of 0 are negative integers. What about on the right side of 0? The integers on the right side of 0 are positive integers. Let us now have the rectangular coordinate system. It consists of two real number lines that intersect at a right angle. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. These two number lines define a flat surface called a plane, and each point on this plane is associated with an ordered pair of real numbers, x, y. The first number is called the x-coordinate, and the second number is called the y-coordinate. The intersection of the two axes is known as the origin, which corresponds to the point 0, 0. Let us have the parts. Again, rectangular coordinate system is composed of two number lines. What are those? The horizontal line is the x-axis, and the vertical line is the y-axis, which are perpendicular to each other, then meet at the point of origin 0, 0, and divide the plane into 4 regions called quadrants. They are named in counterclockwise direction starting at the upper right. Any point in quadrant 1 is to the right of the y-axis and above the x-axis. Therefore, the coordinates are both positive. Any point in quadrant 2 is to the left of the y-axis and above the x-axis. The coordinates are negative, positive. Any point in quadrant 3 is to the left of y-axis and below the x-axis. The coordinates are negative, negative. Lastly, any point in quadrant 4 is to the right of y-axis and below the x-axis. The coordinates are positive, negative. Any point on the x-axis or on the y-axis is not in any of the quadrants. Cartesian plane is composed of infinitely many points. Each point is defined by an ordered pair or form xy just like the origin. The first coordinate of a point is called the x-coordinate or the abscissa. The second coordinate of a point is called the y-coordinate or the ordinate. Remember, class, that in alphabet, x always comes before y. You must run on your left or right before going up or down. If you are going up and to the right, the integers are positive. And if you are going down and to the left, the integers are negative. Now, let's practice in finding the coordinates of each given shape. What is the quadrant where the square is located? We have quadrant 2. What about its coordinates? What is the abscissa or x-coordinate? Look at the x-axis. From the origin, count how far is the point to y-axis. That is negative 5. Negative integers are from the left of our x-axis. What about the ordinate or the y-coordinate? Look at the y-axis. From the origin, count how far is the point to x-axis. And that is positive 3. We are going up, therefore our integer is positive. Next, what is the quadrant where the heart is located? We have quadrant 1. What about its coordinates? What is the abscissa or x-coordinate? From the origin, count how far is the point to y-axis. So we have 3. Since we are going to the right of the y-axis, therefore, the integer is positive. What about the ordinate or y-coordinate? From the origin, count how far is the point to x-axis. And that is positive 6. We are going upward from the x-axis. So that is positive. Let's have another one. What quadrant where the moon is located? We have quadrant 3. What about the abscissa or the x-coordinate? From the x-axis, count how far is the point to y-axis. And that is negative 4. What about the ordinate or y-coordinate? Look at the y-axis. From the origin, count how far is the point to x-axis. And that is negative 3. Very good. Looks like you really understand our lesson for today. Now, let me give you a short exercise. Using the coordinate grid of GUCT, answer the following questions that will be posted. Number 1. What is the ordered pair for the location of the police station? And that is 4, negative 4. Next, which location can be found at coordinates 6, 4? And that is house. Next, which location can be found at coordinates -5, -2? We have the City Hall. Next, what is the ordered pair for the location of the school? We have 2, 1. Next, which location can be found at coordinates -4, +5? And that is park. Last, what is the ordered pair for the location of the library? We have -3, -6. For your assignment, given the coordinate plane, identify the coordinates of the following figures. Now, can you think of its uses in our real life? Let's give some examples of how can we apply it. An air traffic controller must know the location of every aircraft in the sky within certain geographic boundaries. In order to describe where each aircraft is situated, coordinates are assigned to each vehicle in the air. Alternatively, the air traffic controller can assign each aircraft certain coordinates, and the aircraft can report to the appropriate location. So, coordinate system is one of the most important part of air transport. Another, we have a projected coordinate system is any coordinate system designed for a flat surface, such as a printed map or a computer screen. Both two-dimensional and three-dimensional Cartesian coordinate systems provide the mechanism for describing geographic location and shape of features using x and y values. Locations of geographic objects are defined relative to the origin. I hope you learned a lot in this lesson. See you on our next video. Bye!